Okay, so we are continuing on in Unit 8. We're going to talk about two-column proofs today. These notes will go on page 63 in your packet. So you can turn to page 63. This is the second problem on the page. So look at the problem there on the bottom. We're going to start with this one first. Now, before we start writing this two-column proof, I'm going to just talk about kind of what they are. So we've already proven triangles are congruent, but we didn't really prove them writing proofs. We just kind of stated the additional information that wasn't given in the picture, and then we said that the triangles were congruent based on whatever theorem, angle side angle, angle side angle side, so forth. So we were kind of on the verge of writing two-column proofs, but we didn't write it out in that format. We didn't write proofs. So that's what we're going to look at today. I'd like you to think of a two-column proof very similar to how you would think of giving directions to a toddler for how to do something, like let's say making a peanut butter and jelly sandwich. So when you are giving directions to a toddler about making a peanut butter and jelly sandwich, you probably would say something like, I would start by gathering all the ingredients. I need peanut butter, I need jelly, I need bread, I need a utensil, a knife or something. Okay, and then you would go through step by step telling them exactly what they needed to do with the peanut butter and the jelly and the knife once they gathered those. So you would think about that logically. You would go in a specific order. Now, does it matter if I put the peanut butter on the bread first or the jelly on first? Not necessarily. So there's a little bit of lenience in the order, but some things the order matters. I have to put I have to get the bread out before I can start putting peanut butter on it. Okay, so there the order does matter. So think of writing two-column proofs as explaining how to make a peanut butter and jelly sandwich to a toddler. You have to be very specific, and your order of some of the statements has to be logical. Like I said, there's a little bit of lenience in order in some cases, but some things have to go in a specific order. The other analogy I'd like to make is that it's also similar to writing a paper. You know, you've written lots of papers. You know that when you're writing a paper, you generally have a thesis and you state that thesis. You know that right off the bat or pretty early on what your thesis is. But then the whole paper is you supporting that thesis with statements, with reasons, with evidence of why whatever it is you're saying is true. And then you get to the end of your paper and you restate your thesis. You've just proven it based on all that evidence that you provided throughout the paper. You restate that thesis and you have your conclusion. A two-column proof is similar. We're trying to prove something. We know all along what it is we're trying to prove. We're going to get there in a logical manner, state what we know and how we know it, and then we will eventually get to whatever it is that we're trying to prove, which is like our thesis statement. So in this problem on page 63 on the bottom, what we're trying to prove is that the two triangles are congruent. We're going to go about it by making statements and providing our reasons. And notice these are two columns, which is why it's called a two-column proof. So the first thing that I'm going to mention is what I know, which was given to me. So the first thing that was given to me is segment RT is perpendicular to segment SP. And how do I know that? I know that because it was given. So I'm going to go over to my diagram and I'm going to mark that. Segment RT is perpendicular to segment SP. So we learned early on that we mark that with the 90-degree angles. So I think I just discovered something. If I mark that with the 90-degree angles, then I think I know from what we learned previously that angle 1 and angle 2 have measure of 90 degrees. Okay? So I have to state that. I can't just assume that the person knows that. Again, I have to be very specific to that toddler. I need to say, get the bread out, get the jelly out, get the peanut butter out, get a knife out. So next, I'm going to state that the measure of angle 1 is 90 degrees, and the measure of angle 2 is 90 degrees. And the reason that I know that, how I know that they both have measure 90 degrees, is because we learned early on the definition of perpendicular. We learned that when we see that perpendicular symbol, it means the measure of the angles is 90 degrees. So our reason is def of perpendicular. You can abbreviate it that way. I don't need to write that twice because that's my reason for both of those statements in number 2. So now I'm going to move on. If the measures are both 90 degrees, then I can see that the measures are equal, which means that the angles are congruent. So I'm going to say that angle 1 is congruent to angle 2. And I know that because I know what congruent means. I know the definition of congruent. Okay. All right. Next, I think we were given another piece of information. We were given that segment ST is congruent to segment TP. And our reason for saying that is, again, it was given to us. So I'm going to mark that in the diagram. ST and TP are congruent. And then I'm looking to see, well, do I have enough information to prove the triangles are congruent? Not quite yet. I only have 2 pieces of information. Now, I have 2 options at this point. I can state that these triangles are I can state that these triangles are right triangles and then use my theorems that involve right triangles, which is the hypotenuse, leg, leg, so forth. Or I can just, I don't need to state that they're right triangles and just use 3 pieces of information. So this is where with proofs you have a couple different options. But again, if you're going to use leg, hypotenuse, leg, so forth, you would have to first state that the triangles are right triangles, because those theorems, hypotenuse, leg, leg, angle, so forth, they are only used when it's a right triangle. So I'm going to not do that, though. I'm not going to use the right triangle. I'm going to use the 3 pieces of information because I see one other thing that we haven't listed yet. I see that segment RT is congruent to itself. And you do need to state that again. Even if it seems obvious, you're talking to a toddler. Think of it that way. So segment RT is congruent to segment RT, and that's because we talked about this last week. That's the reflexive property, and you learned about that in early math classes, reflexive property. Okay, so now I do have 3 pieces of information. I have side, angle, side, and side, angle, side. So I know that the triangles are congruent by side, angle, side. And the triangles are, we have to be careful with the order, S, T, R, and P, T, R. And that's what I was trying to prove. So I'm done with my 2-column proof. Okay. Now, again, I just want to point out that if you did want to use leg, so after we stated segment RT is congruent to segment RT, and we have leg and we have leg. If you wanted to use that instead of side, angle, side, you would have to have an additional statement here. You'd have 7 statements. And after RT congruent to RT, you would say that triangle STR and triangle PTR are right triangles. And then you would say that the triangles are congruent by leg, LL. But again, you would have to first state that the triangles are right triangles before you could use a theorem that's only good for right triangles. The way I did it, I didn't use leg, I used side, angle, side. So they don't have to be right triangles. So all the steps here lead in a logical fashion to what I was trying to prove. Okay. Next, we're going to do, I'm going to go back here, we're going to do the first one on page 63, which is this one. So again, you're going to write your statements and reasons. And we're just going to go one at a time here. So the first statement would be the first thing that they mention in the given, which is segment EN is congruent to segment ET. Congruent, and that's given. All right, and I'm going to mark that. Segment EN and segment ET are congruent, and that's given. Okay. Next, so I'm looking at my figure and I'm trying to decide what that piece of information does for me. Like, how does that help me? I'm going to take that initial statement and I'm going to see where that goes. Now, I'm also seeing other things like vertical angles, but I'm not worried about that yet because the statement that I just made, I need to now support that further. I need to take that further. So I'm not going to worry about the vertical angles yet, even though I see that. I'm thinking, well, what does this tell me? What does segment EN and ET being congruent tell me? Well, it tells me that this triangle here, triangle ETN, is an isosceles triangle. Okay, and I know that because I know what the definition of isosceles triangle is. Okay, now in class somebody said, after we made our first statement, segment EN is congruent to segment ET, somebody said, well then angle 2 and angle 4 are congruent. And I said, well yes they are, but how do you know that? And they said, well because it's an isosceles triangle. I said, but you didn't tell me that it was an isosceles triangle. So again, you're talking to a toddler and you're telling them all of the steps. You're being very explicit and in a logical order of the steps. And you can't tell the toddler to put the peanut butter on the bread if you didn't tell them that they needed bread. You first have to tell them they need bread before you can tell them to put the peanut butter on it. So same thing here. Before I can say that angle 2 and 4 are congruent, because of it being an isosceles triangle, I have to first state that it is an isosceles triangle. So don't forget that step. It's very important. Okay, so now that we've stated that the triangle is isosceles, now we can say that angle 2 is congruent to angle 4. And our reason is that the base angles of an isosceles triangle are congruent. Okay, now we're going to take a break for just a second from this proof because I want to remind you of a property you learned in probably pre-algebra. It's been a while. It's called the transitive property. And we're going to need this property, so that's why I'm reminding you of it. So the transitive property, you first learn with just numbers, and then eventually once you talked about variables in pre-algebra, you learned the transitive property involving variables. And what it says is that if we let x equal something, 5, let's say, okay? If x equals y, but x is 5, well then y is also 5, right? If x equals y and y equals some other variable, z, let's say, well, and again, we're just pretending x is 5 for a second. So if x is y, well, they're both 5, then y is 5, so 5 is also z. Then we can conclude that x equals z. Okay, that's what the transitive property says. If x equals y and y equals z, then x equals z. Basically, the transitive property is just you substituting. So if x is y and y is z, well then I can substitute x in here for y because they're equal, and that means x equals z. Okay, so we're going to need to use that transitive property here. Now, not with numbers or variables like we did here and like you did in pre-algebra, but rather with angles. So I just stated that angle 2 is congruent to angle 4. And we already kind of were thinking in the back of our minds about vertical angles. So I'm noticing that angle 1 and 2 are congruent and 3 and 4 are congruent because I know that they're vertical angles and vertical angles are congruent. But I'm going to be careful with the order that I state that in. So I just stated 2 and 4 were congruent. So I probably want to, if I'm using this transitive property, x to y, y to z, then x to z, I probably want to use the second angle that was mentioned there, which would be 4. 2 to 4, if I can relate 4 to another angle, which I can, then I'll use the transitive property. So I'm going to not worry about 1 and 2 being congruent yet. I'm going to worry about 4 and 3 being congruent. So if angle 2 is congruent to angle 4, and angle 4 is congruent to angle 3, and that's because of vertical angles are congruent. Now, angle 2 to angle 4 to angle 3, that means that angle 2 is congruent to angle 3. Again, we just substituted in here. 2 went in place of 4, which means 2 and 3 are congruent. And our reason is the transitive property. Okay. Similarly, now that we have 2 with 3, I can state what I know about 1 and 2. And I'm going to be careful with my order here because I have 2 and 3 and I want to relate that to 1. So I'm going to say 1 first, congruent to 2 second, and that's because of vertical angles are congruent. Okay, so now let's think about the order here. We have if angle 1 is congruent to 2 and angle 2 is congruent to 3, then we know that angle 1 to 2, 2 to 3, that means that 1 and 3 are congruent. And that's, again, using the transitive property. Okay. So we have just proven what it is that we wanted to prove, which is that angle 1 and 3 are congruent. Okay, and we also used that this is congruent to that, and that this is congruent to that, and they're all congruent to each other because 2 and 4 were congruent. Okay, so now I've marked my diagram correctly. Okay, so we did need to use that transitive property there. And again, certain things have to be given in order. I have to say the triangles isosceles before I can say the base angles of an isosceles triangle are congruent. I have to state the segments are congruent before I can state that the triangle is isosceles. Now this piece here, 2 to 4, then 4 to 3, which means 2 and 3 are congruent. That piece, and 1 to 2 and 2 to 3, therefore 1 and 3, that necessarily doesn't have to go in that order. So again, 2 to 4, 4 to 3 means that 2 to 3, that chunk right there goes together, and that does need to go in that order. But I could have done 1 to 2 and 2 to 3, therefore 1 to 3 before I did that. Okay, so there's a little bit of leniency, but certain things you have to go in a specific order because it has to make sense logically. You want to tell the toddler to get the items out first before he starts biting into the sandwich. You have to make the sandwich first. Okay, so that is our lesson on two-column proof. Okay, so we're going to do one more. This is on the next page, page 64. In class, I kind of had the students work on this one as much as they could by themselves. But let's go ahead and start it. So we have our statements. We have our reasons. The first statement is going to be the first thing that we were told, which is segment BC is perpendicular to segment AB, and segment FE is perpendicular to segment ED, and that's given. So I'm going to mark that in my diagram. All right, I'm going to tell me what that leads me to, which is very similar to that one we did a moment ago, which is that those angles are measure 90 degrees. So the measure of angle B is 90 degrees, and the measure of angle E is also 90 degrees, and that is because of the definition of perpendicular. Okay, so if the angles are 90 degrees, then we can say that we know that the angles are congruent. So angle B is congruent to angle E, and that's based on the definition of congruent. Okay. So what else do we know? Well, we were given a couple other items. We were told that segment AB is congruent to segment DE, and segment AC is congruent to segment DF, and that's given. So I'm going to mark my diagram, ABDE and DF and AC. Okay. So I'm looking at the two triangles. I'm determining if I can say that they're congruent yet. So I have two pieces, and the two pieces are side, and angle is the third piece. So I have side-side angle. Well, side-side angle does not prove two triangles are congruent. So I can't state that they're congruent quite yet by side-side angle, because side-side angle doesn't prove triangles are congruent. But I am noticing that these triangles are right triangles. And so remember, when they're right triangles, you only need two pieces of information. So I'm going to state that next, that triangle ABC and triangle DEF are right triangles. And how do I know that? Because the definition of right triangle. Okay, so because I've stated that they're right triangles, now I can use the theorems that go with right triangles, which would be the leg, hypotenuse, leg, all those different ones that only require two pieces of information. So we have the leg and the hypotenuse, okay, which means even though this is side-side angle, which we normally couldn't prove the triangles are congruent, we can because they're right triangles, so hypotenuse leg works. So I'm ready to state that I know that the triangles are congruent. So triangle ABC is congruent to triangle DEF, and my reason is hypotenuse leg. And now that we know that the triangles are congruent, remember when we first learned about triangles being congruent, we learned that there's 6 pieces of information we know if we have a triangle congruent statement. We know the corresponding angles, and we know the corresponding sides are congruent. Remember I said just go in order. So because the triangles are congruent, then we can state what we're trying to prove, that segment BC is congruent to segment EF. Remember, going in order, B, C, E, F. And we can state that our reason is because the corresponding parts of congruent triangles are congruent. Now, rather than writing all that out, there's a way that we in geometry usually abbreviate that. corresponding C parts P of congruent C triangles T are congruent. CPCTC stands for corresponding parts of congruent triangles are congruent. So after you've stated that the triangles are congruent, you know that the corresponding pieces are congruent. So any of those angles, any of those sides that we didn't already state, we now can state that they are congruent, which is what we were trying to prove. So we are finished. We have proven what we tried to prove, which was segment BC and segment EF are congruent. And that takes care of our lesson on two-column proofs. Now, in class, I did have students finish the rest of page 64. So if you weren't in class, you'll need to do that for homework. Finish up the rest of page 64. And then we did go over that in class. If you have any questions, see me.